is kind of like what we did Tuesday when we were trying to figure out which structures were the same and which ones were different. It's all based on finding this initial main chain or parent chain. The book calls it let's see, what does the book call it? They just call it the chain. So let's take a look at one of these molecules that we drew the other day, like this one. One way we could think of this, and this is what we did on Tuesday, is a long chain of carbons with stuff coming off of the carbons at different points. So we would say, all right, we go 1, 2, 3, 4, 5. The longest chain that we can come up with is 5 carbons long. And then we kind of have this extra one coming off of the third one. Remember when we thought about things that way? That's exactly how the naming works. We just come up with ways of expressing that in words. So what you do, we'll write down the steps here. Identify, number, and name the longest carbon chain. And let's leave a little space for that because we're going to amend that rule in a minute when we see some other stuff. But let's practice what that means. So we would, in this structure, we would take this thing, look at it, say, okay, the longest set of carbon atoms that I can find is 5 atoms long. Does anybody remember the name for a molecule of 5 carbons? So we go back up to this list. Right? You need to know these names. Pentane, right. So that means that this name is going to be pentane. That's not the whole name, but that's going to be the first part of the name here. So we number it, and we write down pentane. We leave a little space, and then our second step is identify and name substituents. We're going to talk about what that is. With their positions. So what that means is we find the substituents, which are things hanging off the main chain. So anything that's not a part of that main chain, is considered a substituent, a thing that's hanging off of it. So in this case, what's hanging off of the main chain? That extra carbon coming off the bottom, right? Yeah. So we have to find a way to both express that that is coming off the third carbon in, and also that it is one carbon, that it's just one carbon coming off. So to do that, we come up with a list of names that are kind of based on the names from up here, but a little bit different because rather than being a complete structure, it's just the things that are hanging off. So the things hanging off are named like this. If it's just one carbon hanging off, just a CH3, we call it methyl. The word for that is methyl. If it's a 2-carbon group hanging off, we call that ethyl. If it's a 3-carbon group hanging off, what do you think we call that? Remember those names from Tuesday? If the 3-carbon group on its own is propane, what do we call it when it's a thing that's hanging off something else? If we're using that same idea. No? No guesses? Propyl. So we take off that ane on the end, and we put a YL to show that it's just coming off of it. Just one of the hangers off, one of the substituents. All right. So in this case, what type of substituent is coming off of that main chain? Methyl, right? It's 1 carbon. So instead of just pentane, the name of this molecule should be methylpentane, to show that there's a methyl, a 1-carbon group coming off of that pentane chain. And that's still not quite specific enough, because remember we had another molecule that we drew that would also be methylpentane, but it's a different molecule. So in order to distinguish those, we need to put a number in front with a little hyphen, and we call this molecule 3-methylpentane because the methyl is coming off of the 3rd carbon on the chain. That's why those numbers become important. The 3rd carbon off the chain, or of the chain, has the methyl group coming off of it. All right. So then what would you name the next molecule there that I drew, the other methylpentane? For methylpentane? So there's actually 2 choices here of how you could name it. Because we could number from left to right and go 1, 2, 3, 4, 5. Or we could number from right to left and go 1, 2, 3, 4, 5. It didn't matter on the first one because 3 is 3. But on this one it does, because we could actually come up with 2 different names. So we could call this 4-methylpentane or 2-methylpentane. And we need a rule to kind of narrow that down, because we don't want to have those be the 2 names for the same thing. So the rule is, and this is what we're going to add up here, we're always going to start our numbering so that substituents have the lowest possible numbers. So based on that rule, which is the better name? 4-methylpentane or 2-methylpentane? 2. So we're going to say the correct name of this one is 2-methylpentane. We've got 3-methylpentane, we've got 2-methylpentane. All right, let's look at the other ones in that group, those isomers of hexane, and try to name them all. We'll go through a couple more together, and then I'll let you work on the last couple.
That's why you give 2-methylpentanes.
What?
That's why you give like 1, 2.
You want the lowest possible numbers. So we need to number from right to left, not left to right. That's why. Okay, let's take a look at this one. Oh, same thing. We're going to go through these steps in that order. Identify, number, and name the longest carbon chain. So what is the longest continuous chain in the structure? How big is it, and where should we start the numbering? So what? Start on the right because that's where the substituents are. And how many do we get? Just 4, right? And by the way, it can be any connected carbons. So we don't have to start here with 1. We could start here. Or we could start here. As long as they're connected together, the furthest we can get is 4. So we'll stick with this one just because it's the most obvious. But be careful with that because the main chain, the longest chain, is not always the horizontal one. Sometimes it goes like this or whatever, depending on the structure. We'll look at some of those examples too. All right, so there's our main chain of 4 carbons. What's the chain of 4 carbons called? Butane, yeah. So that means the end of our name is going to be butane. And the beginning of the name, we have to look for the substituent. So what kind of substituents do we have here that aren't a part of the main chain? There's 2 of them, and they're not connected, right? So that means it's not an ethyl substituent. It's not this. This is 2 carbons that are just connected together. Those 2 are not connected together. So those are actually 2 different methyl substituents. See that? They're both 1 carbon each, and there's 2 of them. So we have to deal with that. Let's write a rule here, and then we'll apply it. For multiple substituents, each one gets a number. Okay. So for instance, 2-methyl, 3-ethyl, or whatever it is. Multiples of the same type get lumped together with a prefix. That means if you have multiple methyls, you might say 2,2 dimethyl, which means there are 2 methyl groups on carbon number 3, or 2, sorry. Or maybe there's a bunch. You could have things like 1, 4, 5 trimethyl. So that would mean 3 different methyl groups. One of them on carbon 1, one of them on carbon 4, one of them on carbon 5. All of these things can get combined together. So you can have 2, 3 dimethyl, 4 ethyl, 6 propyl, whatever. All that stuff can go together in the same name if there's all those things coming off. So with that rule, how would you name the first part of this name? So we got the butane. How would you name the substituents in this particular structure? You want to give it a try? Okay. All right, I'll tell you this one, and then you can work on the next one. So in this one, we've got 2 methyl groups. They're both coming off of carbon number 2. So the way that we express that is to say 2,2 dimethyl. If I can get it to fit in there, methyl. So this molecule is 2,2-dimethylbutane. The other isomer that we found is this one. See if you can come up with its name.
4-dimethyl.
Not quite. So what you want to do is write down, number the chain, find the main one, write its name, and then put the substituents how you think they should be. Yeah, just give it a try. It doesn't have to be right at this point. It's just a first try. Let's see if you can get it on your own. And we'll do a bunch more practice here. All right, so how'd you number this one? Yeah, that's right. So we can go left to right or right to left on this one. And actually, because we've been doing that, let's try a different way of numbering it, just because to show you that it's possible. So we could go 1, 2, 3, 4 and call that the main chain, because it's still 4 carbons, right? So it's just as long as any of the other ones. So let's do that. Let's call that the 4-carbon chain, which is butane. And then our substituents are here and here, which is carbon number 2 and carbon number 3, coming off of 2 and coming off of 3. Those are both 1-carbon methyl groups. So that means that this is going to be a dimethylbutane, a butane with 2 methyl groups. And those methyl groups are coming off of 2 and 3. So that one differs from the one above only by the position of one of those methyl groups. Now, one of the powers of this technique is when you're good at it, it really solves that problem that we had on Tuesday of figuring out which molecules were the same as other ones. Because if they're the same, they have the same name. But if they're different, they have different names. So if you can count your chains out and your substituents and everything correctly, you can determine whether 2 structures are going to be the same or different just by looking at their names. Okay, let's try when they get a little bit bigger. Those were all our isomers, by the way, besides just regular hexane. Oops. All right, see if you can name this one. You got that one? Try this one. You may need to go back to the book or the notes from Tuesday to name the main chains, but please make sure you know those names by exam or by the quiz on Tuesday. Yeah. Really short. Okay. It is. Yeah.
So it's important for Tuesday to know his names?
Yeah.
And is it important to know, I mean, obviously, hexane is carbon.
Correct.
So you need to go further than just knowing that, or do you actually need to know?
Well, knowing that then and these rules, you should be able to fill in the page. Which takes some practice. There'll be 3 of them.
Yeah.
You're not good stuff. Try to follow those rules.
If this worked the way it is here, where I would combine 5 carbon, 1, 2, 3, 4, 5, and then 3 going off.
It's the right idea, yeah, but you're not right. Not 5, it's actually 6. You always want to do 5. So it's
And you would count the one as well.
And there's one more issue. Try it this way, but remember the other rule is always one to show the closest to one possible. Those numbers. So that's the better way to do it is to start here. Big change.
Is that right?
Yeah. Go ahead. Check the other one.
Oh, yeah.
Yeah. Okay, there's 2 coming out. So think about how you that's
What makes it right or wrong? I mean, I'm doing this and you're trying to align things and I'm trying to make this way, I'm counting on this.
so if it follows the rules that you talked about, right?
So you follow the rules, you never done this time.
Right.
You start from one point, and all the way down and circle it. And something that completely works. And then you come in here and you find out, you have 3 substituents that are.
Yep. Coming out for 2.
4. And now you have to go and name it. So then if you go to one substituent is a match. Then you go ethyl, and now you got two.
That's only if they're connections. If they're separate, that's separate.
No,
Because it stands for one, although there's three.
Right.
It's like Thank you.
Yes. What's this? Yeah, but only the other one. Two carbon. This is the upper group. So 3. All right, let's take a look at these. So for the first one, you find the longest chain that you can follow without picking up your pencil, which it looks like everybody found was this one. You also could have gone up to the left at the top, doesn't matter. And then you got to figure out how to number it, whether we start from the top end or the bottom end. In this case, we want to start from the top end because that makes the substituents at a lower number. If you're ever not sure, just try both. Just name it both ways and see which one has the smaller numbers, and that's the right one. You don't have to decide this before you start anything else. You can just do it however, but also check the other direction. So in this case, the best way to number it is to go 1, 2, 3, 4, 5, 6. So I get 6 carbons, which makes it a type of hexane. My substituents are here, here, and here. That's 3 methyl substituents. So 3 methyl means trimethyl. There's 3 of them, trimethyl. We're going to use those same prefixes that we learned back in the covalent compound. So di, tri, tetra, penta, hexa, etc. And then we also need to specify where those 3 methyl groups are, and they're coming off of carbons 2, 3, and 4. So this is 2, 3, 4 dash trimethyl hexane. Good? Get that one? Okay, let's look at the next one. So the next one, again, has a couple different choices for how to make that longest chain. But in this case, one of the choices is just going straight across like this. We could also go down. That part that's going down would also work. So that number is 1, 2, 3, 4, 5, 6, 7. And that makes this a type of heptane, 7 carbons. Okay, let's look at the substituents. We've got one here, a methyl group coming off of 5. And then we've got here, which is a larger substituent. And that's not a dimethyl because both carbons are connected together coming off of the same carbon. So it's just a larger substituent. So what's the name of that type of substituent? Did you find it? Ethyl, right. Ethyl is 2 carbons. So methyl, ethyl, propyl, etc. So a 2 carbon is ethyl, a 1 carbon is methyl, which means when we name this, we have to name each of those separately with their own numbers. So we would call this 3 ethyl, 5 methyl heptane.
Can we do
Yeah, so what happens if you go from right to left? You still get 3 and 5, so it's the same numbers.
no, then it's happened like 3 math.
3 methyl and 5 ethyl instead, yeah. So is that okay? That's okay. It's okay to have those two both be correct. the truly correct way to do it is to always keep it in alphabetical order. So if you can make the E's come before the M's, that's better. But for this class, I won't count it wrong if you go the other way on that. This is the right way, yeah, because 3-ethyl, 5-methyl. But if you called it 3-methyl, 5-ethyl, because you numbered the other way, I wouldn't mark it wrong. So before we go on and look at some other stuff, I want to show you some good ways to study this. Of course, there's the book problems and all that. And there's tons of stuff online about naming alkanes, naming organic molecules. But let's say you were studying with some people, you just want to do your own thing. One thing you can do is just draw your own compounds and then try to name them, or give them to a friend and try to name them. But of course, you want to be able to check if they're right or not, right? So there's actually programs online that can help you do that. If you look up chemical structure to name, you can find some different links. These all do it really the same thing. If you can find the right part of it, let's see. So this is a big open government database where you can actually draw the structure. No, maybe not. Oh yeah, there it is. Okay. So you can like draw the thing. You know, whatever you can come up with, you can draw. And I don't know if you noticed, but underneath here, the name starts coming up right away. So 3,4-dimethylhexane is what we just drew. 3,4-dimethylhexane. So this one, if there's some other junk before it, don't worry about that. We're not going to get into that in this class, but the main name will be there. This is a little bit of a clunkier one. There are some slicker ones out there. That's just the first one I found. Here's another one, a little bit smaller. We can make some giant chain. You know, you can do whatever you want on here, and it'll figure it out for you. Oh, this one's for products. All right, I should have checked this before because this one's not good either. I'll link one on Blackboard because I know I've seen some good ones around the internet. But that's one way to check your stuff. So that's what we're going to do right now. Rather than me showing you some other stuff, I'm going to stop for a second. And I want everybody to draw a structure and then hand it to the person at your table. If you're at a table of 3, hand it like around in a circle, or at least show it around in a circle, and then everybody has to try to name the other person's structure. Don't have a main chain longer than 10, because we haven't learned the names for those. But other than that, draw whatever you want. So draw a line structure, and then ask the people around you to name it. I'll try to find a good place to.
Let's start with 1, 2, 3, 4, 5, 6, 7. What about this going out? Why? I gotta turn the sheet. I got this memorized already. Oh.
Just remember that's probably the reception. I am trusting it.
Hopefully.
I didn't know, I just drew it. It's fine. It's what it is. Do I, you know the name of yours? You're really right. Yeah. Now that's-
Sorry. So do y'all share your structures? Get a name?
Yeah.
Is it right?
Yep. Okay. I'm just trying to make sure I get it.
All right, so once you got your structure name, let's go put them up on the board with the structure and the name, but not the one that you made, the one that you named. So everybody go put the one that you named, draw it, and then put the name up on the board. And then we'll get a whole nice set of structures to look at. Big problem.
I don't know about this shit. I don't know how to try it. Wait,
We write the name too.
But
We write the name of it too.
yep, write the name too. Just want to make sure everybody's on the right track here.
It's just 2 single. Yeah.
So then that's my question.
Yeah, don't worry about it so much. In this case,
All right.
in this case, the numbers are more important. So this name is better. You get 5, 6. The alphabetical thing is going to be inside. Like the lowest numbers is more important.
Oh, okay.
So if you can make the numbers lower, then don't worry about that. But one issue with this name is that you see here, there's 2 of these here, so you can put 2 numbers here. So you can put 2. All right, so take a look at these as they're going up here. It looks like we've got a few more to put up still. But think about the structure and think about the name. And do they match? Does the structure justify the name? Can you find problems with this? Would you name it differently? And let's talk about some of those, because this is a good way of figuring out what are some common mistakes in people trying to name these things. There you go, your fun one.
Mine.
Yeah. But
I can correct that.
yeah, go ahead. Well, is it yours or somebody else? No, leave them there because we'll talk about them together.
Okay.
But where do you? Let me know where you see. So where do you see a mistake? Anybody? Yeah, you can move around a little bit. Some are hard to read. So what's the second one?
Yeah.
So let's look at the second one. It looks like a monster or something. You've got.
Like it's an octane.
Everybody sees this thing here, and it's named as 7-ethyl 3,7-dimethyl octane. So what's the problem?
I'm thinking that like 1, 2, 3, 4, 5, 6, 7, 8, 9.
Yeah, and I see this actually in several of these structures. So this is a really common thing, is not getting the correct longest chain. So it's really easy to want to just go like straight across the middle all the time. That's not always going to be the case. So like for this one, you can get to 8, but you can actually get to 9 if you go 1, 2, 3, 4, 5, 6, 7, 8, 9. Right. So let me get a different color.
Yes.
So if we think of this as the main chain instead, now we've got a very different name. Now it's a 3,3,7 trimethyl nonane.
Can you say again?
Yeah. 3, 3, 7. 3, 7. Trimethyl. All right, does anybody see a similar or other issue with one of these names? Any of them? Over at the very end here? Yeah. Yeah, good catch. So this one over here, it looks like it should just go across 6. But if instead you go 1, 2, 3, 4, 5, 6, 7, and then have substituents here and here, so it would be 2,5-dimethyl heptane. It's actually a 7 chain instead of a 6. The good news about that is when that's an issue, usually it simplifies the substituents. Excuse me. So let's say like, let's see, where's a good example here? Well, like over here. Let's say you pick the wrong chain here, and you end up with these like really weird big substituents that you can't figure out how to name. Chances are that's because you're not finding the main chain properly. And if you go back and really try to find the longest chain, those substituents will all simplify. All right, where are some other issues here? This one? What's wrong with this one?
I forgot the die on the 3, right? There's 2?
2.
Out of the 3?
No. No, there's only one ethyl group here.
Oh yeah, yeah.
If it were diethyl, that would mean like having another one like that. But no, this one looks good to me.
So in that one, they have 2 methyls, right?
This one?
No. The back.
Actually, both of them.
Yeah.
Yeah. So these should be both be dimethyl also. And then you put like lines in between the different ones like that. Or what? Not the last one. The other ones. And then this one should be this one's hard to see, but there should be a dimethyl here because there's 2.
You said number 3 there, you have 2 that are substituents.
This one?
coming off. Yeah. There's not 2 coming off?
2 carbons. So 1, 2 coming off, so that makes it an ethyl group instead of a methyl group. But there aren't 2 separate ones. That's part of the same substituent. If it has one connection to the main carbon, that's one thing together. So we don't say dimethyl or diethyl, we just say ethyl, because there's one of them. Same thing over here. There's 1 propyl and there's 1 methyl. So then you've got 3 ethyl, 4 methyl, 4 propyl, heptane. Okay, that one looks good. Whoops, same issue here. So these are 2 separate substituents. See how they have 2 separate connections to the main chain? So rather than calling this ethyl, we would call it 3 dimethyl, 2 methyl. Oops, where's my L? So look at the difference between 2 methyl substituents, dimethyl, versus ethyl, where the 2 are connected together and only have 1 connection here. And we talked about that one already. All right, anything else that you see on these? Why don't look at this one? This one right? No, this one's not right.
Yeah.
Okay. Can I erase some of these circles and stuff? It's mostly fine. There's one issue, and it's that chain thing again. The longest chain on this should be 1, 2, 3, 4, 5, 6, 7. So it's a 2,3 dimethyl heptane. In other words, you can't have substituents coming off the end.
That's what I was.
I mean, you can't, but you can't have just substituents and nothing else. If there's just something like that, then that means it just extends the chain. Have substituents coming off the end, you'd need like multiple ones.
In the part, in the second one, yeah, over here.
Yeah.
Yes. You did 3375 methyl nonane, right?
Right.
Yeah, but over there we did on the third one dimethyl, and then 2 methyl.
This one?
No, in green one.
Yeah. Oh, you're right. I'm sorry. So since we changed it, you're right. Since we changed it from ethyl to methyl, this should be 2,3,3 trimethyl pentane.
So if we have double one, then also we have to write just one method, right?
If there's just one?
Uh, if it's come from like it's three, right? So
Mhm.
it's in three they come two methods. But if it's a two only, then we have to write die or it's
If there's two of them, it's die. If there's three of them, it's try.
so if something else like it's a four method, just like it's one more.
It would all still go, if they're all methyl groups, they all still go in this group.
Okay. Thank you.
All right. Okay, so this is all good. Seems like everybody's on the right track. A couple little common things here and there, but as you practice this, it'll be fine. So let's talk about some different kinds of substituents that you might see and some different kinds of chains that you might see with our last bit of time here. Another important class of compounds that are very, very similar are called the Cyclo Alkanes. And this is what happens when you have alkanes whose ends connect to form a ring. The smallest possible version of this is this structure, which we could also draw as like in a condensed structure. Oops, CH2. So it's 3 carbons in a ring, each of which has 2 hydrogens. And because there's only 3 points, that kind of looks like a triangle. And the name of the structure would be cyclopropane. So everything stays the same. We still call it propane because it's 3 carbons. We just add this prefix cyclo to show that they're connected in a ring. Right? So any number above 3 can form a ring, and then be called the cyclo version of that alkane. Well, can't draw a square today. Okay, try that again. So this would be cyclobutane, cyclopentane, and so forth. The most common ring in chemistry, in chemical compounds in nature, is the 6-membered ring, which is cyclohexane. We'll be doing some stuff, actually using some cyclohexane as a solvent in, or as a reagent in lab on Tuesday. So when you have a structure that has these parts in it, that needs to be added to the name also. So let's say you have something like this. Now we don't have a number to start numbering, or an end to start numbering at. So instead, we take that ring, that main ring, to be the main chain, the main structure. And we can start numbering anywhere we want on that ring because they're all the same. So we're going to follow our same rules and start numbering wherever the substituents can have the lowest possible number. So that's here. 1, 2, 3, 4, 5, 6. We have to remember to make sure to put cyclohexane at the end, not just hexane, but cyclohexane. And then we can add our substituents just as we did before. In this case, we've got 2 methyl groups on 1 and 1 on 2. So that becomes 1, 1, 2, tri methyl cyclohexane. So it doesn't change any of the rules. We just have to add that extra word cyclo whenever we have a ring structure. We still count the carbons, whatever. And the other thing is that the main chain, the carbons that we use for our main part of our name, are only the ones inside the ring. Let me show you what that means. So if you have something like this, you can't go 1, 2, 3, 4, 5, 6, 7, 8, 9. That doesn't work. When you see that ring structure, you only count the carbons inside that ring as the carbons in the main part of the chain. So this is also a cyclohexane, and this would just be propyl cyclohexane, or maybe 1-propyl. If there's only one thing attached, we don't really need the 1 because it doesn't matter where 1 is, but to be consistent, we can call it that. So you can't go from numbering the ring to numbering the chain. You can't do both. You got to pick one or the other. The rule is whichever one's bigger comes the parent. So if you've got a 6-membered ring with just a 3-carbon group coming off, then the 6-membered ring becomes the parent cyclohexane. Yeah.
Propyl, when we use it's a when it's a 3 in 1.
Yeah. A 3-carbon group.
So how we use a like dimethyl when it's a 2, then it's a 3 in 1 chain, then we have to write propyl.
No, so like in this case, if there are 3 separate 1-carbon groups that all have their own connections.
Like it's a double one, right?
Yeah, so this is ethyl.
Yeah, so it's a tri. Oh, sorry.
Dimethyl, ethyl.
Ethyl, sorry. Yeah.
And then the 3 is propyl when it's all connected to one spot. All right, so that's cyclo, yeah.
So what if we have one that's the same number of the little things coming out?
Yeah.
It's the same as the third thing or whatever. Then what? Does it matter how you write
I think you go either way at that point. Yeah.
Oh.
I think it doesn't matter. I don't know either. I don't think it matters. I don't know, let's see. So like you got a 5-membered ring of cyclopentane that then has 5 carbons coming off of it like this. What do you call that? Let's see. So I guess they say that the ring takes precedence there, and they call it pentyl cyclopentane. Sure. Yeah. Yeah. But if we made one more on this, oh no, see, that's wrong. Because if there's more, it should be cyclopentyl hexane. But anyway, it doesn't really matter. That kind of stuff is not what I want you to concern yourselves with. This is what's important, just being able to come up with a unique name that uniquely identifies the thing. All right, last thing, one more type of substituents, which are very common in these types of molecules, is halogens. So halogens can also be substituents, and they have their own names. So you've got fluorine, chlorine, bromine, and iodine. And their names are pretty simple. We just put an O at the end instead of the suffix. So this is fluoro, chloro, bromo, and iodo. And all the other rules apply to those just the same way too. But now we can build some pretty good structures. All right, so this will be maybe our last one for the day. See if you can give that one a name. No, you don't like that?
I just stared.
No, that's the neat thing about these rules is it doesn't matter how big or complicated the structure is. If you go step by step and like you'd find the chain and then you find the things and you put them in name by name, you're going to get it right. You're going to get the right thing. Even if there's a whole bunch of things and the name ends up this long. You keep following those rules, they keep working. Okay, same thing. All right, how do you feel about this one? It's complicated. It is complicated. Yeah. But let's go through the steps. So first you find the longest chain. Where's the longest chain? 6. That would be like here, right?
Yeah.
It's tempting to want to go just straight across, but that's only 5. Take a turn and go up, you can get to 6. All right, so where are we going to start numbering? Yeah, we can look at both of these. This is one of those ones where you may want to try it both ways so you can see. So if we start from the right, that would be 1, 2, 3, 4, 5, 6. So this is hexane. And the things attached are in alphabetical order. 5,5 dichloro, 2 fluoro. I'm going to run out of room. 3 methylhexane. Yes. So it's sorry. It's just chloro. It's chloro and then dimethyl. So I'm wrong here. Hold on. Let's try that again. Thank you for catching that. All right. So I got methyl groups at 5 and 3. And then I've got chloro at 5 and fluoro at 2. So that's going to be 5 chloro, 2 fluoro, 3, 5 dimethylhexane. If we numbered the other way, from left to right, we'd get 2 chloro, 5 fluoro, 2 4 dimethylhexane. Yeah.
We have following that alphabetic, right? Like
Yeah.
First A, B.
Yeah.
Then don't we have to use before F, like dimethyl?
Yeah, so you don't count the di. So it's M. But again, as I said before, don't worry about that kind of stuff. That's not what I want you to focus on. If you can come up with a name that gets all the substituents in the right place, then it's a unique name and it's good. And it's worth all the points. Yeah.
I read like 2,4-dimethyl, 2-chloro, 5-fluorohexane.
Yeah.
Is that right?
That's right. Yeah. So if you mix those order around, that's still right.
Yeah.
The point is to get the numbers. So numbering wise, I guess it's better to have, yeah, the second one is better numbering wise because it has lower numbers overall. You see that? So this one is 2355 and this one is 2245. So that's lower numbers. So this one is better. Okay. Thanks, everybody. Happy studying. Quiz Tuesday on all this fun stuff. I'm thinking it's going to be a paper and pencil kind of quiz because you got to be able to draw structures and things. So we'll probably take it offline and just do a paper and pencil quiz this time.
Don't talk too much hard questions.
Okay.